So now we have these questions that we need to finish up. Okay, the first question, that is question A, says solve the equation. Now I don't want us to start with this one here. Okay, let's start with these questions here. Factorize completely. There's a reason why I want us to start with this one, because the ideas that we are going to use here, or if you can understand the knowledge which you need to answer these questions, it will be easy to solve that equation there. Okay, so let's start with this one here. Okay, this one here. Okay, so we need to factorize. Okay, so factorization involves looking for a factor on both sides of the common factor on both sides of the operand or the operation sign. In this case, the operation sign is negative, right? So the common factor on both sides, we can say is 1, right? We don't show 1 in mathematics. We don't write that one, but I'll write it so that it opens up your mind. Okay, yes. So our common factor here is 1, right? So what are we remaining with there? We are remaining with x squared minus 16, right? Because x squared divided by 1, it's x squared. Negative 16 divided by 1, that's still 16, right? And here we still have x squared. Now what we have to do is to write 16 in index form. Okay, one way we can write 16 in index form is by squaring 4. Okay, we haven't changed anything. It's just another way of writing 16 in index form, right? Now the last step that you have to do is to write here what is inside the brackets in difference of 2 squares, right? So we have 4 there, and we have x. So the first bracket is carrying the positive sign, and the second one is going to carry the negative sign. This is the only way we can be able to prove. Okay, because when you factorize, whenever you perform factorization, if you multiply your product, you need to get back to the question. So look at this. If we multiply x times x, we are getting back to x squared, right? Then positive 4 times negative 4, we are getting back to negative 4 x, which is 16, being written in that form, that is in index form. So you see that from here we are going to the previous step. Then from here, it's same as we have that one. Wow, if we simplify, and from here it will get back to the question that we are given, right? Okay, so you don't need to show this one here. I just had to write it so that I help you to understand what is happening. Okay, now let's use the same knowledge to the second question, that is question B. What is the factor? Our factor here, our common factor is just 4, right? Yes. Do we have any variable which is common on both sides of the operand sign? No, it's just 4. Now see that 4 into 20 is going to give you 4, right? Remaining with x squared there, minus 4 into 16, that will give you 4 again, right? Okay, so here we are getting 4. So here we need to write 4 in index form, which can be written as 2 squared, right? And then here we have x squared. Another 4 we need to write on both sides. We are writing the constants in index form. So also this 4 can be written in index form as x squared. So there we have 4. Writing this in difference of 2 squares, we have 2x, right? 2x, plus 2, and then open bracket here. Okay, you have you get the second bracket, which will carry a negative operand, which is x, which is 2x, okay, minus 2, right? Yep, that's it. It can be like this, or you can factorize further than this. Even that one is okay. Or we can say, oh, you can also get 4 if you want, right? Here, factorizing, you can have 2, right? X plus 1, right? You are going to have this. And then factorizing, what is common there, you have 2 outside the bracket. Then you can have your x, right? You have your x minus 1, right? Yes. So we have factorized these questions completely. Anyway, there's this one, the last one here. So let's see how we are going to deal with it. Okay, so this one here. So what are we going to do to factorize this one completely? Okay, so this one is not different from these two that we have solved. The idea is still the same. Okay, look at this one here, just this part alone here. Okay, compare this one to this stage here. Okay, this one here, how are they? And also compare the one down. Okay, this part here. Okay, okay, just the denominators. You see that you are able to write the constant numbers in the index form, and you're able to factorize, right? So that already tells you how to go about it. Okay, so that's what you're going to do. The first thing we'll do is to write the constant numbers that we have in index form. So we have b there, b squared, it will be like that, but 5 can be written as 5 squared, right? Minus 4 can be written as 2 squared, right? Divide by a there will stay like that. Okay, and then we can write this in different of 2 squares, right? We can write what we have here in difference of 2 squares. Okay, that is, we have b. Okay, we get 1b there, we get 5, right? So this one can carry a positive operation sign. Then here we can have 2, we get 1, and there. Okay, then the second one will carry a negative sign, so we have the remaining b and the remaining 5, right? That is the remaining 5 minus the remaining 2 divided by the remaining a. Okay, so we are done with this question again. Okay, so now we can use this knowledge that we have used to solve these 3 questions to solve this equation here. Okay, so this equation that we have, how can we solve it? Okay, so to solve this question, you can use completing the square method. You can solve this one by factorization method, or you can use the formula method. Okay, but we're just going to use remember, this is paper 1, you don't use a calculator, so you can just use either completing the square method or factorization method, which we are going to use. Okay, so how do you do that one? So what you do is you multiply the first term. Okay, you multiply the first term and the second and the constant term, right? So you multiply excuse me. So if we multiply 2 and 3, we are getting 6, right? We are getting 6. Okay, now what you have to do here, this is the way the method I use. Okay, you find, remember, this is 6 is the product of 2 times 2 times 3, right? Okay, this is what is giving me 6. Okay, I'm getting 6, isn't it? So after getting that 6, now check out this one here. Okay, check this. Okay, we proceed. We're looking at the quotient here, right? So the method that I use, which you can also use, if the equation that you are solving has the quotient here, okay, this is what we call the quotient, and constant is here, right? Okay, the quotient for the x squared, or rather the quotient of x squared, okay, and the constant. So multiplying the quotient and the constant, it gives you 6, right? So you look at this number that you have gotten, which is your product. You look at it and think of this number here, okay, this number that is 5 5x here, okay. So from this number that the product that you've gotten, which is 6, you can divide this 6 by the number, the smallest number, which can go into 6 without giving you any remainder, and that will give you 3, right? And then the number which can go into 3 without giving you any remainder apart from 1 is 3 itself, right? And then from here, 3 into 3, you just get 1, and 1 is the only number which can go into 1 without giving you any remainder, right? So we just end here. Usually this we don't consider them, but sometimes we do, especially if the number that you can use is just that very number that you have found and 1, like in this case. See, if we add 2, if we multiply 2 and 3, we are going to get back 6, right? Yes, and that is, it is satisfying our condition there. What should happen if we multiply the quotient? If we multiply two numbers that we have found, we need to get the product that we got from the quotient and the constant, right? So 2 and 3, isn't it? Now how about if we have 6, right? Multiply by 6 and 1. If we use 6 and 1, can't it work? Because if we multiply 6 times 1, we are going to get 6, right? And then subtracting 6 minus 1, we are going to get positive 5, right? Which is here in between, right? Yes. So here on 5x, the other way we can use 5, we can write 5x using the sum and the product here that we have gotten. We have gotten the product here, which is 6, right? And the sum that we are getting is 5. And those two numbers which are giving us the sum and the product, it's 6 and 1, right? So in short, the other form we can write 5x is using 6 and 1 by subtracting, or rather adding the variable to 6 and also adding the variable to 1, which will just be x, because we don't show 1 in mathematics, right? It's a unity, okay? So where there is 5x, we are going to replace with 6x minus 1. We haven't changed anything here. It's just another form of writing 5x, right? And then we keep in mind that if we multiply 6 times 1, we are getting back the product, which is 6, right? So let's substitute here. To substitute, we're going to get 2x squared. So where we have 5x, we're going to substitute with positive 6x, right? Positive 6x minus x. So it's just another way of what we still have here is 5x. We haven't changed anything. Minus 3 is equal to 0. Okay. I don't want you to memorize this, okay, the method. I want you to understand what is happening, okay, and then you can use any reasoning, any mathematical reasoning, and you'll be able to get this question correct. Okay, so what do you do here now? You use factorization method, but how do you do that? Okay, you divide your mathematical expression in two. Okay, now this side you can factorize. Since you have two terms, you can look for the factor, okay, of the operand on both sides of the operation sign, which is positive. That is 2x squared and 6x. The common factor is just 2, that is the value, which is the constant. And then for the variable, you have x is common, right? So what are you remaining with here? You are remaining with x plus 2x into 6x. X and x goes by cancellation method, and you are going to get just 3, right? How about this side? Okay, so this side you have negative. What is the factor here? The common factor is again 1. I'm going to show it so that it opens up your mind there. You understand what is happening, but you don't need to show it, okay, because it is a unit. Okay, and we don't show a unit. Yes. All right, we'll discuss that about a unit in detail in some other units, okay, some other lessons. So we have negative